1.4, where functions meet, and our discriminant is going to come up again. If you put a quadratic function and a linear function, meaning a straight line, in the coordinate plane, only three things could happen. That straight line could cut the parabola, that means hit it twice. That straight line could touch the parabola, that means hit it once. Oh, and by the way, there's a special word for that. They are tangent to each other. Tangent means touches without going through. Or they could completely miss each other and have no points of intersection. But it's important that you understand that the word tangent means you're touching a curve without going through the curve. But again, cutting means twice, touching means once. And then we just do our work. It says find the coordinates of the points of intersection of the graphs with those two equations. So I have a parabola and I have a straight line without using technology. So this is just algebra skills. Well, how would you figure out where two things intersect? What do you do? Algebraically, how am I going to do this? Anybody that wants to just say it. Yeah. He says plug in for y, which basically means set them equal to each other. Because when you're trying to figure out where two graphs intersect in space, you're literally saying, where are the places where these two lines are equal to one another? So you just say x squared minus x minus 18 equals x minus 3. And because we're dealing with things that have exponents, you need to get everything to one side in order to solve it. I like my x squareds to stay positive. So I'm going to move that x and that negative 3 over to the left. So that means I'm subtracting an x. Now I have negative 2x. I'm adding a 3. Now I have negative 15. And it's just a regular old quadratic now. I just solve for x. And it factors, which we should have known it was going to because they said do it without technology. So you're looking for the two numbers that multiply to be negative 15 and add to be negative 2. It's going to be negative 5 and positive 3. So we have two solutions. We have one, and I'm going to list them from small to big, when x is negative 3, and we have one when x is positive 5. Easy peasy? Not too bad, right? Set them equal, get it all to one side, solve for x using whatever method's appropriate. So click your heels because you're happy, ready to move on to the next question? Yes?
Wait,
yeah.
Mr. McCutcheon,
Yeah.
don't you have to find the coordinates, so you would plug in each of those values in where y is?
And there it is.
Thank you.
That's what I was going to say. So everybody in the room that moved on to the next question missed the last 1 or 2 points of that question. Because it doesn't say solve for x. It says find the coordinates. IB likes to get tricky with their words. So yeah, you know how to do the question, but you got to pay attention. If they ask for coordinates, you need ordered pairs. So we do have to plug in our x's to solve for y. And it doesn't matter where you plug it in, but this is the really easy place to plug them in. So if you plug in negative 3 to that line, you get negative 3 minus 3, which is where we're going to get negative 6. And you plug in 5 to that line, you will get 2. Those are the coordinates. Gotta watch them. They play with the words. Good news is that it probably only would have cost you 1 point. But what stinks is you deserve that point. You know how to do that. It's got to watch their words. Now, I'm not trying to trick you. Now, we good to move? Everybody's good to move? Okay. I wasn't trying to trick you. I wouldn't lie to you twice. Got him. Kidding. Tricked you again. There we go. So you've been given 2 parabolas. This time, not a straight line and a parabola. 2 parabolas. Part A says solve the equality. Part B is part B for a reason. They want you to solve the inequality. So why did they do that? Because it scaffolds the question for you. If this was an IB question, part A would have said solve for x. Part B would have said hence solve the inequality. Because when you solve quadratic inequalities, what you're tracking down are critical values so you could put them on your sign diagram, right? Well, those critical values are always where you get the solution of 0, which means you solved for x. So part A sets you up for success on part B. Is that what that noise is? They're drilling? Oh, because we couldn't figure out what it was yesterday. Okay, we're going to want to get everything to one side. And like I said, I like my x squareds to be positive. So in order for my x squareds to be positive, I have to move everything to the right side. So that means I'm subtracting an x squared from both sides. Now I only have 1. I'm subtracting 5x from 2x, so I have negative 3x. And then subtracting 6 from negative 4 gives me negative 10. And once again, this does factor. Now, we weren't told to do it by hand, but because it factors, we just do it by hand. The two numbers that multiply to negative 10 and add to negative 3 are negative 5 and positive 2. Giving you solutions of, because it didn't ask for coordinates, x equals negative 2 and positive 5. Now, part B wants you to solve the inequality. So I'm going to write it again, just so I can make a point. I'm going to have to squeeze these things in here. I have to write a little bit smaller. Write a little bit skinnier, I guess you could say. Suck it in for. Okay, we made it. All right. Oops. I put an equal sign instead of the greater than symbol. I know. There we go. Now it's fixed. Now, I told you when I was doing the equals one, I like to keep my x squareds positive, right? So I moved everything to the right. So this would say 0 is bigger than the quadratic x squared minus 3x minus 10. So if 0 is bigger than a number, what does that tell you about that number? You can say it louder. Yeah. It's negative. So what we're supposed to be doing is figuring out where the parabola is negative, because it says 0 is bigger than the parabola. You put your two solutions that you found on your sign diagram, and those two solutions were negative 2 and positive 5. And you test the three zones, and you're looking for the one where your parabola is negative, because negative numbers are smaller than 0. So you just throw a number like negative 3 in, and I'm going to be cheating a little bit. I'm going to be throwing them in over here just to test the symbol. So if I throw negative 3 in, I get negative number times negative number, which is positive. And then you could throw in something that's between negative 2 and 5, like 0. That gives you negative number times positive number. That's negative. Found part of our solution. And then a number bigger than 5, like 6. 6 minus 5 is positive. 6 plus 2 is positive. It is positive. So as an interval notation, what would my answer be? We're overthinking it. Any one of you can tell me, I don't care.
The parenthesis negative 2 comma 5
Yes,
parenthesis.
perfect. Parentheses. You cannot include the negative 2 and the 5.
Oh no, I can watch it now.
Because the negative 2 and the 5 are where they're equal to each other. That was why in part A you were solving for where they were equal. In part B, they specifically said one is larger than the other. So you can't use brackets. Brackets is where they were equal to each other at negative 2, at 5. Cool? This is set up like an IB question, a lower level IB question, like maybe a 2, maybe a 3, okay? But it is set up that way where part A would say solve for x, and then part B would say hence solve the inequality. They were really trying to set you up for success when they do that. That is one of the hardest things for students to learn, is to understand that if a question has 2, 3, 4 parts, every one of those parts was there for a reason, and it means something for further down the question. For example, Did any of you a couple years ago, not Liam, yeah, was it Liam Hines or was it wasn't Liam, it was the year after that. Oh, crud, now I forgot his name. Well, anyway, kid was in HL Math. He was the only student we had in HL Math that year. He worked with Miss Bluebaum every week after school doing the HL material, and during the regular week, he was in my room learning, quote unquote, the SL material. Because HL is like SL plus 20% more. Well, anyway, one day she comes to me and she goes, we can't figure out, we're looking at the mark scheme. We see that the answer makes sense, but we have no idea where this line of logic came from. It looks like it doesn't flow from the line before. She's like, I couldn't figure it out. My husband couldn't figure it out, which, by the way, he was my AP Calculus teacher. And she's like, and the kid can't figure it out. And the three of us are just scratching our head. What's going on? And I was like, I don't know. I'll get back with you later. Let me take a peekaboo at it. And I stared and I stared and I was like, what did they do? What did they do? And then I realized eventually I was like, oh, this answer from part D, this one step of logic, came from a statement in part A. And then I went to her and I was like, there, it's right there in part A. They said it for you. You didn't have to think your way to it. They told you. And she was like, oh my goodness. And I was like, yeah, we did the student thing and forgot it's all one question. So that is that's one of the hardest parts about learning the IB style is realize all the parts mean something. Mm-hmm.
So like if they give you like a given statement and then you went and solved for that statement later on, you get a point off.
No, you just would have worked too hard. So if they give you something for free and then you work to find that thing and then use it, you don't get anything off, but you won't get any bonus points for finding the given thing. So that's what they did. They gave a line of logic, that trig logic at the top. It was some kind of trig identity that would have been really hard to prove, and you were supposed to have used it to get to the final answer, but that was in part D. You were supposed to go all the way back to part A and be like, oh, that's what makes life easy, and then use it. It was just one of those things. Question or good? Will they ever give you unnecessary information? Generally not. Generally, because they're not trying to throw a student off. So they won't be like, here's some extra data about birds. Oh, by the way, how fast is this car going? They don't do that because there's no reason to. It's just like, why punish a student for not reducing a fraction? There's no reason to. So they just look, they will challenge you in every way you can imagine, but they're not going to try to trick you. That's not what they're trying to do. And the last example for today, I'm going to give myself a little more space just because I have to write larger than you do. It says, figure out where this straight line, which, by the way, you don't know its y-intercept. Well, we have to solve for the y-intercept. It says this straight line and that parabola are tangent to each other. Solve for k. What that means is this line touches the parabola, does not go through the parabola. That's what that means. So first of all, we know at one point in space, they are equal to one another. We know that. And our job is to figure out where that's going to happen. Well, it's quadratic, right? You get everything to one side. So subtract 2x and subtract k. 2x squared minus 5x, and then plus 4 minus k. Now, this was the thing that Chris and I were kind of talking about a while back, and we were talking about finding the domain of something really, really nasty, is when you're treating this thing at the back as a constant. That is your C value. You know there's one solution. So that tells you your discriminant equals 0. So at this point, you would find your discriminant, set it equal to 0, and solve for k. I could draw a better 4, I promise. There. Okay, what was that? 25 minus 32 plus 4k. I just did -4 times 2 times 4. So that got me my negative. Oh, that should have been plus 8k. My apologies. That's what I get for distributing in my head. Basically, I just pretended this was an 8, and I distributed an 8. -8 to 4, -8 to -k. That's what I did. And you go, okay, well, 25 minus 32 is -7. Add 7 to both sides and divide by 8. I got to come up here. Adding 7 to both sides gets me here, and then dividing by 8 gets me to k equals 7/8. Oh, we must have messed up. The answer's a fraction. No, it happens a lot. It happens a lot, actually. You'll get used to it. It's not a big deal. That question's neat. But it would normally be harder than that. It would normally say something like, they would say something like, this straight line and this parabola, this straight line cuts the parabola. Find all the values of k that make that possible. So you would have done the exact same work, but at that point you would have said, oh, the discriminant must be strictly positive. And to be honest with you, usually the discriminant would itself been a quadratic in terms of k, and you would have had to have factored it and used a sign diagram on k and given them a span of numbers where that straight line and that parabola would intersect each other twice. That is more likely to be what happens. And that's probably what the kind of stuff that I gave you in the homework is too. Any questions on this one? Or is it feeling not too bad? But you see, the discriminant's incredibly important. Most important thing in the chapter. The discriminant needs to equal 0 because you were told they're tangent, which means they only touch each other one time. So it could be, a parabola and then a straight line like this.
In the line that went, it wasn't like it went through the parabola.
Went through the parabola?
But only touched it once.
That's impossible. So you can't go through the parabola one time and only touch it once. Not possible. The only way it's possible is if it's a vertical line.
Yeah.
If it's a vertical line, the axis of symmetry is the only straight line that goes through the parabola exactly once.
Why?
Because the parabola is open out to left and right forever.
Okay, so what if it's, well, why does it have to be the axis of symmetry?
Well, I mean, let's see. If your slope was steep enough, I guess it's possible.
No, if it's a vertical line.
Well, yeah, any vertical line. I didn't say the only vertical line. I said it's the only line. But now that I'm thinking about it, if it was steep, if your slope was steep enough, you could go through it exactly once, I guess.
It has to be vertical because as this parabola goes on, it becomes steeper and steeper.
Yeah, that's right, because the parabola gets steeper and steeper and steeper, yeah.
Steep.
Yeah, so only vertical lines can go through the parabola one time.
Okay.
That's the only way. And since we don't like to mess with vertical lines, you don't have to worry about it. Yeah, that's not tangent. If you go through something, it's not tangent. Tangent means it touched it and kept going without going through it. Yeah, a smooch. Yeah, I gave it a smooch. That's fun. That made it to the recording.